right. Hello, everyone, and welcome to the NANOG 85 Hackathon introduction. My name's Aaron. I'm co-chair of the Hackathon committee here at NANOG. Appreciate you all taking the time to join today. We'll be doing a quick walkthrough of what you can expect from the Hackathon, logistics, ways to communicate, our infrastructure that we'll be providing, and as well the theme for this NANOG 85 Hackathon. Will be available for questions and so forth at the end if you have any. Let's get started. So a bit about the Hackathon as a little overview. The Hackathon is part of NANOG's educational mission. We aim to provide this experience such that knowledge can be shared amongst participants to help foster new ideas that will help the community and the participants grow. A bit of logistics here on the slide. So given that this upcoming NANOG will be held in Montreal, we like to go with local time for all of the below listed date and timestamps. So in Montreal, we'll be going by Eastern Daylight Time, which is UTC -4. The Hackathon happens the weekend before the General Conference. So that's Saturday, June 4th to Sunday, June 5th. Hacking will be going from 1 p.m. or 1300 on Saturday, again, EDT, to 5 p.m. or 1700 Sunday. Mentors will be available to help. We'll talk about that more in a bit and how you can reach us. From Saturday, 1 p.m. until 4 p.m. And keep in mind with Saturday, we will actually not have a room at the conference hotel. Saturday will be entirely virtual. Sunday, however, mentors will be available from noon to 5 and will as well be providing a room. There are like 2 conjoining rooms at the hotel from 9 a.m. to 6 p.m. Only on Sunday, June 5th. So talking about how you can reach the mentors and other members of the Hackathon on Saturday virtually and so forth on how to like collaborate with your teams. We primarily use Slack and Zoom. Slack is pretty much the primary way to get a hold of everyone on the fly, especially the mentors. Everyone should be a member of the NANOG 85 Hackathon Slack channel. If you registered for the Hackathon, you should have already received that information. If not, feel free to reach us at the end of this and we'll be sure to get you into that channel and the Slack in general. Team Slack channels can, of course, be created. Feel free to do so. If you want to reach mentors, we have a user group within the Slack. You can just use @mentors and it will ping all of us. We'll be sure to get back to you ASAP. We kindly ask that you do not use @here or @channel as they will create notifications for everybody either in the channel or currently active. And we don't want to really distract anyone from their work during the Hackathon as best as possible. So we kindly ask you do not use those @here and @channel things. Having an up-to-date Zoom client, of course, is a good idea. We will be providing a Zoom room for both Saturday and Sunday. For, of course, Saturday, everyone will be a virtual attendee, but even if Sunday, if you can't make it in person, we'll have that Zoom available for collaboration. And you'll generally as well find mentors that are not going to be attending in person as well in that Zoom room for any general question you want to ask them, not over Slack. And as well, we just want to be clear that for whatever reason, if you have any issue of any kind, please do not hesitate to reach out to the mentors, even if that means privately, by all means. So the theme this time around, we decided to go with what we're calling projects that make a difference. The idea is to develop improvements for important tools that we feel have a significant contribution to the community, significant impact, and so forth. We did have a CFP for this. So later on in this presentation for going over basically maintainers of projects that make a difference, we'll be spotlighting or showcasing in a moment one of those that's submitted to our CFP. So stay tuned for that. Of course, you can work on whatever you like at the Hackathon. However, this will be kind of like the the centralized theme that we would ask for you to participate in if you could. It doesn't necessarily have to be the project that we are showcasing, but that's kind of the general idea of like finding a code base or a project that you feel that would make a significant impact towards network operating engineers, or in general the network engineering community. We will as well be providing infrastructure. So if you have any kind of project that you are working on that you would like to actually test out on, like, for example, a virtual router, we provide Arista and Juniper container routers with CentOS boxes as well as hosts for you to experiment on as kind of like a playground. And we'll be covering that a little bit more in detail later. Each instance has prepared Docker containers, as I said, which you can see a quick glimpse of here in terms of a topology. And every team, in terms of the infrastructure, it will be an AWS instance with public IPv4 and IPv6 addresses. Going out to teams, if you have a team, fantastic. If not, no worries. We'll be able to help you out after this introduction, or even on Saturday. If so, yeah, no worries about teams. We're all a huge collective here, one way or another. And then finally, closing out my spiel here. The way we close the hackathon is each group is invited to present their work at 5 p.m. on Sunday, 1700. So we'll follow up with additional details then. Of course, as I mentioned earlier in the call, we will have a room on Sunday at the conference hotel where we'll be showcasing all of your work that you contributed to this time around. Just to give a quick heads up, we will be doing some interviewing during and after the hackathon, only if you're open to it. We'll ask you kindly. You can expect just like general questions of how'd you hear about the hackathon, how'd you like participating, and along that kind of line of questioning. So that, as is mentioned in the slide, will be hopefully added to a short video that will be part of the general session showcasing the hackathon and what you all worked on over the weekend. This time around, PeeringDB, who we've had before submit projects for the hackathon, was one of the contributors to the CFP that we felt was a well-detailed project that was worth showcasing here. And so at this point, I'd like to actually hand it off to Leo, who I think has some prepared material to show you all.
We've participated in the NANOG hackathon a couple of times before, and each time we've participated, we've learned something from it. And one of the things we learned from the last hackathon was it can be difficult for someone who is new to interconnection to participate in a hackathon if they don't have a good understanding of networking. And also, of course, sometimes someone will come to a hackathon and they'll have a good understanding of one language and the software that the project they would like to work on is actually developed in something else. So we've slightly adjusted our approach this time, and what we're trying to do is we're trying to introduce people to PeeringDB, and we're trying to design a feature rather than develop it. So quickly, the headline is PeeringDB is sort of like a yellow pages for interconnection. Networks, internet exchange points, and facilities are listed in PeeringDB. About 25,000 networks, which is about 1 in 3 of the networks that you will find in the routing table. So as PeeringDB has developed and sort of increased its reach, the process for introducing new entries to PeeringDB has had to develop as well. And we got some new guidelines approved for introducing new interconnection facilities, which is buildings where networks interconnect. And in order to implement those new guidelines, we need some software. So this is roughly the workflow that we need to turn into some kind of software design. The idea is that there is someone who is new to PeeringDB, and they say, hey, I've got an interconnection facility and I'd like to register. And we don't know who they are, which in the olden days we perhaps would have. And therefore, we want to make sure that they're not just a bot who's going to try and use PeeringDB to distribute their spam. So the plan is that they will get a unique URL of some kind, and networks or IXPs will have 90 days to essentially go to that URL and click, I'm a PeeringDB user. I say that this is a real interconnection facility. If they get that after 90 days or within the 90 days, then exit to the happy path and we go and create the registration. If it fails, there is some kind of polite notification saying you didn't make it, sorry. And presumably they could try again, maybe not. That's sort of up to the design. Our offer to you as potential volunteers on this project is that we will teach you a little bit about PeeringDB, and through PeeringDB, you'll have a window into the NANOG community. Obviously, we can't teach you everything, but this is a good place to understand how networks, internet exchange points, interconnection facilities, and so on go and do their stuff, which could be useful. We will work on a design, discuss how different cases could work. And then the goal is that we will have some kind of design that we could be delivering to developers. Now, if we do really well, we might be able to come up with some kind of Scratch implementation as well, but that would definitely be the icing on the cake. It's not the objective. Now, I will be sharing this deck of slides, which is a Google thing, and there are links here to getting started developing for PeeringDB and good first issues. If you want to go and develop something else for PeeringDB and not work on this particular project, then you can definitely take a look at some of those good first issues. And that webpage there has some advice on how to set up our development environment and how to go about putting the code into place. But if you don't want to do the coding and you just want to design the feature, then we have a project for you. And that is it. So I'm going to hand back.
Chris, if you don't mind going through a walkthrough of our infrastructure.
So if you've been to the last couple hackathons, this will all sound pretty familiar because we've landed on a good model for the lab infrastructure, and we've been mainly iterating on it since then. So a few hackathons ago, we landed on Container Lab as a infrastructure provider. It's an open source project mainly funded by Nokia. So as always, thanks to Nokia for their support in helping us get this up and running. And I just realized there's a typo here because we're actually not running Nokia instances; they're Juniper instances now. So Container Lab is a system for creating container-based network infrastructure. It comes with a definition language, a configuration language for bringing up container-based OSs or container images, provisioning, setting provisioning links between them, which is probably the most important part, using Docker and namespace and capabilities to create the topology as you need it. So we have a standard infrastructure that we designed. And each team on request, we will provision an instance. So this will be an AWS EC2 instance. There is a shared SSH key for the instances. So we will give you access to that SSH key, and you'll use that to reach the instance. And then once in the instance, you have access to the different containerized router OSs, as well as a pair of CentOS nodes that you can use as development hosts that are part of the infrastructure as well. If you would like to spin up, change the topology or spin up additional containers, add anything to it, there are the container OSs we're using are not the only ones that are supported. So we're happy to work with you if you'd like to create something more custom than what we're providing. We put a key in the Slack channel, and then you use that private key to access the container assigned to your team. Several ways to access them. You can always create an SSH tunnel, which gives you which you can use to get direct access to the containers from your desktop if needed. You can always develop locally and then push your code to the device, or just run everything on the remote servers directly. Just as an FYI, these are ephemeral instances. They're not going to be kept beyond the hackathon. What we'll probably do is turn them off after the hackathon closes next Sunday, and keep the instances stopped, which preserves their file systems, and then most likely a week or so later delete them entirely. So if you need any files off of your instance within that week or during NANOG, please let me know. We can bring it back up and get you access to it. But anything, back up anything that you want to keep. So this is the topology and the address plan. It's fairly simple and straightforward. There are two routers running CEOS, which is Arista's containerized version of EOS. We have two containers running CRPD, which is Juniper's containerized router OS, which is not quite Junos, but close enough for most tasks. It is effectively, it's not the full stack Junos. It is the CRPD daemon and associated support utilities running in a container. So some of the commands are slightly different, and some of them are Unix commands, not Junos CLI commands. So I found a couple of those so far, and you might find more yourself as you go. Everything is dual stack v6, IPv4 and IPv6. And all of the routing between the four routers are eBGP sessions, where each device has its own AS number. To access the lab using your SSH key, important thing to remember, I get tripped on this myself all the time. When you download an SSH key and drop it into your .ssh directory on macOS Linux, do not forget to change its owner permissions. SSH key-based authentication does not work unless the key file is mode 600 and only readable by your username. And then use that to authenticate with the instance. And just here's an example of that. If you download the key, drop it into your SSH. This chown and chmod command here is the important bit. Otherwise, you're going to get errors that may not be obvious. And then once you're there, you can simply, something I've learned is that you don't actually need the -I switch to specify the key. As long as that key is in the .ssh directory in your home directory, SSH will pick it up and use it. And then once you're in, you'll get the fingerprint prompt as usual, and then you will have access to your instance. Make sure to use the Ubuntu username. That's the default username for these instances. And as that implies, if you want to install packages, use Ubuntu's package management utilities to do so. A bit about Container Lab. The control utility for running Container Lab is called CLab. I'm just going to show you an example of a couple commands that you can run. This is probably the basic one to show you what is actually running. And you'll see there are the 6 containers with their names, and these names are what you will use to access them. And it tells you what images and the kind. The kind is a CLab specific field, so it's got internal logic to know how to handle the various vendor containers it supports. If you want to reach them by their IP address instead of Docker exec commands, these are the IP addresses that each container gets assigned for external access. So if you want to create a tunnel from your desktop directly to an instance, this is the destination IP for your SSH tunnel command that you would use. If you're familiar with Docker, the process for getting into one of your containers is the Docker exec Docker exec command, which effectively gives you terminal on the instance. Now, remember, these are all Linux-based containers, so by default, you will not get into the router's exec command line. You'll just get a bash prompt. So the exec argument is slightly different between Arista and Juniper. The difference is that the C and CLI is capitalized for the Arista containers. So just a subtle difference, but an important one. Okay, and here's an example of reaching the CLI on one of the COS instances. This is the previous iteration of the lab, but the command is the same. So you Docker exec IT, the name of your container, and then the exec command. CLI for COS with the C capitalized, CLI with the C not capitalized for the CRPD instances. For those of you who don't have familiarity with the Arista's EOS, if you know Cisco, you are 90% there. Arista's EOS is so similar to Cisco that Cisco actually sued Arista over this at one point. And you'll find a lot of familiarity once you get into the Arista exec commands. Configure T works as you would expect. With the one twist is that there is a configure session command, which makes it a lot easier to create candidate configs, very similar to Juniper's config mode, where you make your config changes and then commit. And here's a link to their config language if you'd like to reference that. Also, most of us here have a lot of familiarity with Arista. Feel free to hit us up if you want to do any specific configurations that you're not 100% on how to do. We are here to help. CRPD, like I said, is a containerized version of the Junos routing daemon, the RPD daemon. It is not a full Juniper OS. And what that means is that you have this strange dichotomy of some commands that you're familiar with on a Juniper work exactly as you'd expect, and others do not. The ones that do not tend to be the more basic exec commands. For example, ping, ARP, are not available in the exec mode. You have to drop to the shell to run those, which takes some getting used to. Next slide. I think I put in some examples of those. Show BGP summary, exactly the same output that you'd see on a real Juniper router, but if you try to ping, it doesn't recognize that. So next slide. That's where you would use the start shell command, and that gets you to to a bash shell. And then from there, you can run Unix level commands that are underneath. So ping, arp, netstat, even the IP route commands work here. Because all that CRPD doing is populating the Linux kernel route table. So something to understand is that, as I've said, we've been iterating on this topology for a while. So if you're logged into your instance, you'll see that these are the definition files. So these are the files that define the topology. We've left the topology file for the last hackathon in here. So the main difference is that the last hackathon we were using SR Linux containers. For this one, we swapped in the Juniper ones mainly because of greater familiarity with Junos versus Nokia's OS. So if you look at the current version of the CLab definition file, so this is Container Labs configuration. You have definitions of here. This is the management network. We have the kind keywords, and we have those linked to the images. So we know that this kind matches this container image. From here, we have definitions for the nodes. And if you look into this directory, you'll see the startup configs that each one uses. And you can edit those at your leisure. And if you restart the lab, they will use the new configurations. There's a startup script that is linked that goes into CentOS, and this sets up the basic networking for the CentOS instances. So you can log into those, and in a properly functioning lab, the two CentOS instances should be able to reach each other. If you bring up your lab and you cannot ping CentOS 2 from CentOS 1, please let me know. The magic bit down here is the definition of the virtual links. So if you want to create a new, if you want to add an image or add a node, you need to make sure that you also define links that define which ports those nodes connect to on the old ones. Now, because these are all containerized OSs, they all use Linux style interface definitions. ETH0 is always the management, so you'll start at ETH1. Now, these don't translate to these exact interface names once you're in the router OS, but at least the numbers will be the same. I think COS it becomes Ethernet 1, not ETH1. So if you want to change your topology, this is the file that you would work with to do that. It's actually symlinked this file, but you get the idea. What I would actually recommend is copying this. If you want to change it, copying this, make a new file, and then change the symlink to point to the edited file. Now everything is going to require sudo. So both CLab and Docker commands require sudo. So this command gives you the running instances, and you get almost the same information if you run a Docker PS. You'll see here the same image names, but this gives you some additional information about from Docker's point of view of the commands of the images. Now, redeploying this is fairly easy, and I can do that for you live. CLab destroy -t now CLab.yaml. This is going to shut down the lab. And no containers found. So to redeploy, you use the clab deploy command, and you always want to have this -t to point to the YAML file. So we're creating the containers, creating the instances. You generally want to give it a minute or two for the actual daemons to spin up after the instance itself launches, but it's waiting for that to complete now. There have been some times where if you log in immediately after you get the prompt back, it may not be completely booted. So, and here's our lab. So, as I said, the mechanism for reaching your instance reaching any of these containers is going to be the docker exec command. And for Arista, it's going to be CLI capitalized. Okay. Here's our router. See, we have a full routing field. So here are all of our V6 routes. So if I want to get back out, and CentOS, it's Linux, so you're just going to use the bash. And this, all of your standard routing works here. If we go back to the topology, 10.100.1.2 is CentOS, is the CentOS 2 image. And we have connectivity. And V6 connectivity as well is all operational. So and then okay. Oh. And here is your CRPG with notice that your interfaces are the same Unix name, so Ethernet 1, ETH2, but with the same Juniper Unit 0, Family INET, INET 6. Routing options, BGP protocols and policy, pretty much configured the way that you expect it on a main Juniper. But again, traceroute works. We have traceroute, but ping is not a known command. Show interfaces gives you some of these don't give you the same thing you expect. Show interface description is one that I noticed that doesn't give you everything. Yeah, monitor doesn't work the way that you would. Some of these things are just missing. It's a partial implementation. But if there's something you're trying to do and running into trouble, again, we're here to help. Reach out and let us know if you're running into any issues. But if Junos to get to the Unix shell. Start shell is your go-to command, and then from here you can run your ping command. ARP works. Those are the two that I found that you need to drop into shell to get. And then the Unix IP commands work as you expect. Yeah, just show. You get the V. I'm trying to remember how you get the V6 table. Oh. I have completely blanked on this. Anyway, so I will Google a man page to remember that command. Thank you very much. Again, we're in the channel if you have any questions. And thank you very much.
Thanks, Chris. Okay, well, thank you all for joining today. I hope to see you all Saturday on June 4th, and have a great rest of your week.